All right, let's do this question together. Another question. This is a question on regression. Okay, so given the data, right, and the label y as this, and so you have some data, and given this data, its label is 1, 2, 3. The idea of regression is that you ideally want to find some function such that when you put this value in, you get this value out. Okay? You put this one in, you get this out. You put this in, you get this out. So how do we find this function? Well, what we normally do is that we just assume that this function look like something. Like, and in this particular case, I tell you what the function look like. In real life, you will have to pick your own function. But the whole process is the same. So here is the function that I'm telling you. Let's try to fit this function with the data. So this function, it's a line, and it doesn't have to be a line. It could be x squared, x. There's a lot of things that could go in here. But what you need to know is that now that you have this function, you want to find the W1 and W2 such that it gives you the best fit, right? Right now, like I said, if you plug this in, you want to get this out. So given that we have 3 points, so why don't we plug the first point in? So if you plug first point into x, then it's going to be 0 times W1 and then plus W2 times 1. And ideally, we wanted to output 1. So given 3 points, we're going to be able to get 3 equations out of it. In the second equation, second point, right, we know that if we plug 1 in here, times W1 plus W2 times 1, it's going to equal to 2. So that's from this equation here. And the third point tells us that if we plug 2 into this function, times W1 is equal to W2 times 1 is equal to 3. Now, I keep putting 1 here, but you know if you multiply by 1, it's the same thing. There's a reason why I do that. It's because you can rewrite this whole thing into matrix format. If you rewrite this into the matrix format, then it's going to look like this. 0, 1, 1, 1, 2, 1. Okay. Now remember, if this is x squared, then all these values will have to get squared, right? So on the exam, you really gotta pay attention what the function is, right? Depending on the function, this matrix will look very different. Anyway, so if this multiplied by W1, W2, then it will give you 1, 2, 3. Okay? Now, once again, we can rewrite this as x a w equals to y. Well, this case, we can't invert this. All right? If you can't invert something like this because it's a tall matrix, and you can't invert a tall matrix, well, when you have situations like that, then what you want to do is essentially find the pseudo inverse. So the pseudo inverse, the symbol for it is like a cross. So that's the pseudo inverse. If you find the pseudo inverse, then this cancels out, and now you have the equation. So the key is to find the pseudo inverse. So how do you find the pseudo inverse? Well, the problem with this is that it's not square and symmetric. And you can always turn a matrix square symmetric this way. A transpose A, right? So by doing this, you convert a tall matrix into a square and symmetric matrix. Now you can find the inverse. So A transpose A, inverse A transpose A, W is equal to A transpose A inverse A transpose Y. So notice I multiplied this on both sides. And with the inverse, this now cancels out. And you get W is equal to A transpose A inverse A transpose Y. So here is this is what you want, right? If you can do this, then the problem is solved. So why don't we then solve this? What is A transpose A? Let's take a look. We have A transpose would be 0, 1, 2. Actually, let me write it. Let me write it here. A transpose A is equal to 0, 1, 2, 1, 1, 1, and then 0, 1, 2, 1, 1, 1, which is equal to, let's see, 0. Nope, that's not right. This is a 5. Yeah. And this one is 3, 3, 3. Now, did I do that right? I think I did. This is 1 times 1, 4, 5, 3, 3, 3. Yes. So now we want to find the inverse. So A transpose A inverse is equal to, well, you're going to do this determinant, right? 1 over the determinant. So the determinant is divided by 1 over 15 minus 9. 15 minus 9, I hope I did that correctly. And then you flip these two. Now it's 3, 5. And then minus 3, minus 3. So that should be the inverse. So this gives us 1 over 6. 3 minus 3, minus 3, and 5. Okay, now if we multiply, this means that W is equal to, we got the inverse as 1, 6, 3 minus 3 minus 3, 5, times A transpose. What is A transpose? 0, 1, 2, 1, 1, 1, times Y. What is Y? I think Y is here, right? 1, 2, 3. So Y is equal to 1, 2, 3. Okay, so this is all we have to do. This is equal to 1, 6, 3 minus 3 minus 3, 5. And I'm going to multiply the 2 together. So this will be 6, 8. Right? I think I did the math right. 6, 7, 8. Yeah. And this one would be 6. And this would be 6. And this, wait, is that 6? Let me double check. No, that's it. So 6, 7, 8, 5, 6. Yeah, so this is it. Now, let's see what I can do. What would be an easier method? I think it'd be easy if I do this. 1/2 minus 1/2. Would this be easier? Minus 1/2, 5, 6. Maybe. Let's find out. 8, 6. So this is equal to 4 minus 3. Oh yeah, it is easier. 4 minus 3. And then this will be minus 4 plus 5, I think. Which give us 1 and 1. Yeah, I think that's it. 8, 4, 3, 4, 6, 5. Yeah, this turned out to be the fastest way. And there it is. We have 1, 1. And now it's saying that if W1 is 1 and W2 is 1, then it will give us a function that gives us a good prediction. So let's see. W1 is 1, therefore it's just x plus 1. All right, that means if we plug in 0 is equal to 0 plus 1 is equal to 1. Check, did a pretty good job. now let's plug 1 in. Will be 1 plus 1 equal to 2. Check. 2 equals 2 plus 1 is equal to 3. Check. So in this particular case, I mean, I made the question very simple, so you guys can solve it. But this is the general idea of how to solve this problem. Now, it's the part that trips most people up is that you gotta really pay attention to the function you're using. Like, this is a simple function, but if I had put x squared and x here, right? So this implies that the matrix would have been 0, 0. But when you plug 1 in, that'll be 1 and let me see, 1 and 1. And if you plug 2 in, that'll be 4 and 2. Okay, so the A matrix will be different. I keep repeating this. Make sure you pay attention to this function. All right, don't just assume it's always going to be linear. All right, so this is how you would solve a regression problem. Regression. All right. Good luck.